Alright, an introduction to area drainage system, J. Paul Geyer. He was the editor. Introduction, hydrology, hydraulics, erosion control, riprap, protection, subsurface drainage. His publications adapt and unified facility criteria United States government which are public domain has authorized for unlimited distribution and are not copyrighted. Our introduction. Purpose scope. The purpose of this course is to provide an introduction to normal quantity design surface of the drainage system for residential, commercial, institutional, industrial developments. Sound engineering practice should be allowed, filed with the unusual special requirements of counter general investigations, on-site investigation system site, the tributary area with the prerequisites to stay with the drainage requirements. Information regarding capacity, elevation, conditions, existing drains will be obtained. Topographic size and shape of the drainage area, extent of the type of the development, profile of the cross-section, roughness data of the pertinent existing streams and water course location. Possibility of ponds area will be determined through knowledge of climatic conditions, precipitation characteristics, essential adequate information regarding soil conditions, including types, permittable or perviousness, vegetative cover depth, and to and move of the subsurface water with the depth of the frost and secured all outflow, downflow conditions, including high water occurrences. High frequencies also must be determined. Effective drainage construction, local interest facilities, local requirements that will affect the design of the drainage works will be evaluated. Division of rainout proposed. Particular effort made to avoid resultant downstream conditions, unfavorable public relations, causing litigation, damage claims, agreement that needed to obtain drainage easement, and avoid interference with water rights will be determined by the time and the design consumed prior to the initiation of construction. Possible adverse effects for the water quality due to disposable drainage waterways involved with the water supply system will be evaluated. 1.3 Environmental considerations. Surface the drainage system will either be beneficial or adversely environmental impacts affecting water, land, ecology, social, economic consideration affects the surrounding land. Vegetation may cause a change of the various conditions of existing environment, such as surface water quantity, quality, groundwater level, the quality, drainage area with the animal, aquatic life, and land uses. Environmental attributed to lay with the water could include such items as erosion, flood potential, flood variation, biochemical oxygen demand content of dissolved solids, nutrients, coliform or organisms. They also may be possible to attribute to consider evaluating environmental impacts, both beneficial and adverse, including effects of surface water and groundwater. R2, hydrology. Hydrology includes the careful appraisal of the factors affecting the storm runoff that ensure the development of the drainage system controls works capable of providing the required degree of the protection selected for the design. Storm magnitude that depends not only on the protection sought, but also for the type of the construction consummated with the consequence of the storm of the drain. Storm greater magnitude than the design of the ground condition affecting runoff may be selected with existing anticipated aerial development, and also characteristics seasonal time and occurrence of the design rainfall for areas up to 1 square mile where only peak discharge is required, but the design extent of the ponding is not involved with the computation runoff normally accomplished for the scale of the rational method. For larger areas, suitable unit hydrograph data that is available to where detailed consideration on ponding is required. Computation should be a unit hydrograph and flowing procedures. Design storm. For such development, portion of the installation administrative of the industrial residential area of the design storm normally based on the rainfall of 10-year frequency potential damage operational requirements may warrant more severe criteria of the current certain storage recreational areas. Less criterion may be appropriate. Less criterion may also be employed with the regions where storms and appreciable magnitude are infrequent. Either damage of the operational capabilities or such for the large expenditure for the drainage are not justified. The design of the roadway culverts are normally based on the 10-year rainfall. Example, the condition greater than 10-year rainfall may be used on areas of steep slope with overflows would cause severe erosion, damage to highway road, fills, impound large quantities of the water, primary diversion structure, important bridges, critical facilities where uninterrupted operations and permanent protection against flood flows. Originating from the area's exterior of the design area will normally be based on 25-year greater rainfall, aging Again, depending on operational requirement, the cost beneficial consideration, nature, consequence of flood damage, result of the failure of the protective work, justification for selected design storm percent, if and appropriate with the comparative cost of the damages for the alternative design should be included. Rainfall intensity will determine the best available intensity, duration, frequency data with the best information for the type will be taken. Such publication, Rainfall Frequently Atlas, United States Technical Paper number 40. Generalized estimates probable maximum precipitation rain frequency tab of the Puerto Rico and Virgin Islands, technical paper number 42. Rain frequency Atlas of the Hawaiian Islands, number 43. Probable maximum precipitation rainfall frequency data Alaska, technical paper number 47. The publication may be supplemented appropriate with more detailed publications and study of the local rainfall records for large area that studies involving unit hydrography and hydrography. Flow rating procedures of appropriate design storm must be synthesized from aerial time distribution characteristics of typical regional rainfalls. For some areas, it might be reasonable to be assumed that the ground would be covered with snow. With the design, rainfall occurs and snow melts would be added to the runoff. Should noted, however, the rate of the snow melt under range of meteorological conditions normally encountered with the drain design would seldom exceed 0.2 inches per hour, could be substantially less than that rate. 226. In selecting design storm making other decisions, particular attention must be given to the hazard life of the other disaster consequence of resulting failure protective works during a great flood. Potential hazard situation may be brought to the attention using services of other concern. Appropriate steps can be taken. Infiltration and other losses. Principal factors affecting the computation of the runoff from rainfall with the design, drainage, and system compromise, initial loss to infiltration, transitory storage, some cases percolation in the natural stream beds. Necessary data available to the excellent indication of the magnitude of these factors can be derived through the analysis of the past storm's record flows with the unit hydrograph approach. At the onset of the storm, some rainfall effectively retain and wetting down vegetation on other surfaces. Satisfy soil moisture deficiency, filling surface of the depression, retention capacity vary considerably according to the surface and soil type. Cover antecedent moisture conditions for high intensity design storms of the convection thunderstorm. Maximum initial loss up to 1 inch may be assumed for the first hour of storm precipitation, but usual values range between 0.25 to 0.5 inches per hour. If design rainfall intensity is expected to be occurring during a storm, long duration, substantial amount of the immediately prior rain with the retention capacity would have been satisfied prior to rain, no further assumption loss shall be made. Infiltration rate is dependent on the type of the soil, the vegetal cover, and the use of the area that's subject to the rates. Decrease the duration rainfall, but the increase of the type of the value of the infiltration. Generalized soil classification shown in the table 2.1. These infiltration rates of uncompacted soil studies indicate compacted soil decreased infiltration rates between 25 to 75% of the difference, depending on the degree of compaction. Soil type vegetation generally decreases the infiltration capacity of the coarse soils and increase with the clay soils. Show the description soil group symbol in infiltration inches per hour, and that was sand and gravel mixtures, silty gravel, silty sand, organic well development, silty clay and sandy clay, or inorganic and organic, and bare rock not highly fractured. Alright, peak rates of runoff that reduce the effect of the transitory storage water course minimum ponds among the drainage route with effects reflective of the C factor, the rational formula, and shape of the unit hydrography. Flow routing techniques must be used to predict major storage efforts for the cover of the national topography. Man-made developments in this area. Stream bed percolation loss of the direct runoff to be considered only with the sandy alluvial watercourse such as found within arid, semi-arid regions. Rate of stream bed percolation commonly range from 0.15 to 0.5 cubic feet per second per acre wetted area. Runoff computations, 2.4 design procedure. The drainage facility would involve the computation for the convert the rainfall intensity expected during the design storm with the runoff rate for which be with the size of the various elements for the storm drain system. There are two basic approaches. First, direct estimate of the proportion of average rainfall intensity that will appear with the peak off the rate runoff rate with the second hydrographing Methods of the depict with the time distribution runoff of the bends for the counting loss for the attenuation with the flow over the surface of the point of design versus approach is amplified with a rational method which even the large majority of engineering offices in the United States can be employed with successful, consistent with the experienced designer of the drainage areas up to 1 square mile in size. Design construction sanitary stem sewers ASCE Manual number 37, the airport drainage FAA AC 150-5320. 5B explaining the illustrated use of the method. The modified method is outlined below. Second approach encompasses analysis of the unit hydrograph techniques to synthesize complete runoff of the hydrographing. To complete peak runoff, the empirical formula question is Q equals C times 1 minus F. Can be determined and defined in Appendix B, but the equation is now known as modified rational method. C is the coefficient expressing the percent of the peak runoff of the produced loss for the other infloration and the attenuation owing with the transitory storage value depends primarily on the source of the surface irregularities tributary area. Although accurate value of the C cannot readily be determined for most development area, the apparent value ranges between 0.6 to 1.0. However, the value of the less than low is 0.20 for C may be assumed in low an area of low density design, rainfall, high infiltration rates, of flat terrain. A value of 0.6 may be assumed for the areas left upgraded with a meandering flow. Appreciable natural ponding exists. Slopes of 1% or less vegetal cover. Relative density and value of 1.0 may be assumed that applicable to the paved areas. If the smooth areas, substantial slope with virtually no potential of surface storage and little no vegetal cover. The design intensity is selected with appropriate intensity, duration, frequency relation with the critical time of the concentrate for the design storm frequency. Time concentration usually determined and defined with the time required under the design storm condition for the runoff travel the remote point of the drainage area to the point in question. Computing time concentration should be kept in mind that even unfamiliar glare bare turf ground overland flow sheet form will rarely travel more than 300-400 feet before becoming channelized, then moving relatively faster. Also, the design practical minimum time concentration for roofs, paved areas for relatively small unpaved areas upstream of the most inlet of the drainage system, 10 minutes. Smaller values are relatively rarely justifiable. Values up to 20 minutes may be either the result of the runoff excess. This will not cause appreciable damage. A minimum time of 20 minutes is generally applicable for the preserved areas. For the configuration, most remote portion of the drainage area must be such that the time concentration length marked through this design intensity peak runoff will decrease substantially. In such case, the upper portion of the drainage area shall be ignored, and peak flow computations should be based only on the more efficient downstream portion. For all duration, infiltration rate with assumed with a constant amount of the established flow of the rainfall 1 hour duration. Whenever F varies with the considerable of the given drainage of the air with the weighted rate with the maybe U with the N must be remembered. However, the various previous portions may require individual consideration because of the weight of the overall value. For F, it's proper only when the rainfall intensities are equal to or greater than the higher infiltration rate within the drainage area of the design military construction drainage system. Factors such as initial rainfall, love of the channels, percolation rarely enter the runoff computations above the rational methods, such as losses accounting for the selection of C, the coefficient, where basic hydraulic data on concurrent rainfall runoff of the adequate to determine the hydrographing of the drainage area with the uncertainty inherent with the applicable rational method that can largely be implemented with the IOSS rates. Determine the unit hydrographic analysis record flow provide with a good base for the estimating loss rates for storm, the design magnitude, all flow rates, and storage effect for the count with the shape of the unit hydrograph with the basic data with the inadequate with the determination unit hydrographs used may be with the empirical method to synthesize the unit's hydrograph method with particular desirable where the design is being developed with the pond of detention reservoirs, pump stations where peak runoff large tributary area with involved with the design where large scale protective works for the under consideration. Here volume during the transforming storm runoff of the opposed with the peak flow with the maybe principle of the design criteria with the determining dimensions of hydraulic structures. Procedure for routing storm runoff through reservoir type storage and through stream channels can be found with a publication listed in the appendix and available publications on these subjects. Alright, hydraulics. Design. Hydraulic design required element system of the drain for the project to work initiated with the air after functional design criteria. Basic hydrologic data that may be determined with the hydraulic design continues with their two primary considerations, namely the flow quantity for which the system will be subject and the potential of the kinetic energy momentum that they present. These considerations required by the hydraulic grade line would then indicate with the energy grade line with the design pertinent and relative to the quantity of flow computed that the conditions where energy loss dissipated most could be carefully analyzed with the phenomena occurred with the flow of the water above the low of the critical depth and the change. One of these flow classes and another must be recognized where water velocity must be carefully computed not only in connection to energy to momentum consideration also in order to establish extent of the drain lines of the water course subject with erosion, deposition, sediment, thus enabling determination of the countermeasures needed with the computed velocity the possible resulting adjustment basic design layout often affect with certain parts of the hydrology. Manning's equation is most commonly used to compute the mean velocity of the essential horizontal flow that occurs with most elements of a system, which is the V is equal to 1.486 times n, divided by n times r to 2 to the third and s to 1.1 In terms of define an appendix value of the use of the formula contained with the professional literature. 3-2 channels. Open channels are an area of the range with a graded swell with a bladed with a ditch with a large channel with a rectangular trapezoidal cross-section. Swells are commonly used with a surface range or graded areas around the buildings within the housing developed with a central triangular in cross-section with some bottom rounding with a very flat side of slope. Normally detailed computation for these flow carrying capacity required. This is commonly used with a collection on the surface of the water with the outlying area of the lawn on the roadside shoulder with the large open channels, which may be either wholly with the ground, partially formed with the levees, for the principle for the permitting drain with the upstream flow with the diversion of these parts of the drain system, which build up the area with the construction of the covered drains, which unduly costly, otherwise impractical. There, you with the rainfall, the drainage disposal aware with the channel line, with the depends with the erosion characteristics, the most possible, the greatest maintenance requirements available to space, overall comparative with cost, the other factor with the needing providing with the safety fence was not less than 4 feet high along larger channels, especially with those carrying water. High velocity will be considered with the particular vicinity of the residential area. Discussion that flow will not attempt to cover all the items designed open channel, however the will and type of the structure of the design feature with the required special consideration. Apart from the limitation of the gradient imposed with available space with the existing utility drain confluences desirable to avoid flow with the near critical depths of that small chain with the cross-sectional roughness sediment with the transport will cause instability with flow depth varying wide above and below with the critical reason of the intra-flow stability ratio of the inverted slope. Critical slope should not be less than 1.29 supercritical flow, no greater than 0.76 for the subcritical flow. Online area of the channel gradients should be chosen with the will product with a stable subcritical flow with a non-erosive velocity in the region with the mosquito-borne. These are prevalent. Pay attention for the must be given the selection with gradients for the open channel with the minimized formation of the breeding areas. Recommended maximum permissible velocity or the Freud numbers of the non-erosive flow of the given the professional literature channel with the velocity Freud numbers of the flow with the control with the providing drop structures or other any energy dissipators to limit extent with the widening of the channel with the less decrease of the flow of the depths of the increase of the roughness by in depth and non-erosive flow cannot be entire and contained channel could be lined with the floor turf of the asphalt, lodic, Portland, cement, concrete, ungrounded, routed rubble, small ditches, half section of the pipe that can also call it through care but must be taken to prevent interest with the side erosion, undermining ultimate displacement. Individual section choice of the material depends on velocity, depth, and the turbulence involved with the quantities availability with the cost of material and elevation of the maintenance of the choice of the material and effect with the flow of the character that may be an important factor. Further, an impervious lining is to be used with no needs subdraining with the ear and protection must be considered. Where serious with the drops of the structure that is proposed, the care must be taken in avoiding placing them too far apart and to ensure that they will not undermine the score of the foot of the overpour with the design energy dissipators being with the score protection are discussed subsequently. Side slopes for unlined earth channels normally will no step of the 1 to 3 order minimize maintenance permit machine mowing of grass or weeds. Side slope with the steepness of the move paved channels will depend on the type of the material used, met with the placement available space and accessibility requirements, maintenance of the equipment economy. Portland cement concrete is used for line spacing. Overall economic consideration dictate even the rectangular channel. Even through wall forms that are required rectangular channel with a particular desire for conveyancy and subcritical channel flow. Most channels, however, will convey with the subcritical flow with a trapezoidal cross-section relatively large earth channels involving levees. Side slopes will depend primarily on the stability of materials used. and allows for freeboards above the computed water surface of the rate channel, provided with a during design storm for the channel with not overflow for the reason minor variations, hydrology, future development, minor super elevation flow at the curve of the formation waves, unexpected hydraulic performance, embankment settlement, and the like, and allowing for the normally ranges from 0.5 feet to 3 feet, depending on the type of the construction site of the channel. Consequently, overflow the degree of the safety desired requirements are greater for the levee channel, whether those who leave with the ground because of the need with the guard against the overtopping, breaching embankments where failure would cause the sudden, highly damaging release of the water for areas upstream of the culvert and bridges. The free allowance should include the possible rises of the water surface elevation due to currents greater than the design runoff with unforeseen entrance conditions, blockage by debris. Our velocity flow effective with the entrained air of the flow of the depth should be considered. Alright, whenever the water flow with the covered alignment at super elevation of the water surface will occur with the amount depending on the velocity of the degree of the curvature, further the water enters with the curve that's flowing with a super critical velocity. A wave will be formed with the surface of the initial point with the change of the direction. This wave will be reflected back with the curve of the channel in a zigzag fashion, travel the curve of the long distance along with the downstream tangent with respect to the rise of the water surface less than 0.5 half a foot. Normally would ignore because of the regular with the channel for freeboard allowance others able to contain them. Where rise with a substantial channel with a height that can be held at the minimum corresponding economically achieved by super elevation channel bottom and to fit with the water for the super elevation and with the formation transverse wave supercritical flow be effectively eliminated by providing spiral for each end of the curved super elevating channel for the transition horizontal full tilt accomplished with the spiral. Figure 3.1 charter indicating with the formulas pertaining to the computer design wall heights are typical super elevation conditions. For practical reasons, spirals generally used are modified with the type of the existing series area with a circular area with the equal length with decreasing radius, experimenting with the shown with the curve to be super elevated length with a spiral transition L to LT may be short and safe minimum be given in the following equation. LT is equal to 15 times V to squared times T divided by R to C and G. The spirals will be the non-super elevated channel minimum length of the LS is required. LS is equal to 1.82 V times T divided by GD 1.5. In terms of both the question defined in appendix B with the rise of the water surface of the outstanding bank of the curved channel with the trapezoidal section can be a system A for the use of the preceding formulas. Show the depth subcritical flow section and depth of greater and less than subcritical flow. Horizontal invert, no spiral. Horizontal invert, spiral transition. Elevated invert, spiral transition. Horizontal invert with or without spiral transition. Alright, for most open channels, confluences, proper design can be accomplished satisfactorily with the computation based with the principle of the conservation momentum with the channel flow with the supercritical with the excess of the wave of the turbulence are likely to occur unless the close of the balance force and achieve the such confluences with the makes of the minimum disturbance rules of the tributary inflow made with the enter of the main channel in the direction parallel to the main flow with the design depth of the velocity with the temperature inflow are made equal to the load of the main channel. Further, even though the minimum disturbance for the period likely under such design conditions it must be, remember the natural flood flows are highly variable among both magnitude of the distribution. Since variability leads the unbalanced force of accompanying with the turbulence need many well exist. Some additional wall height and freeboard allowances with the end downstream confluence structure. Side inflows to the channel that generally enter over the top of the walls or within the cover drain through the wall with the main channel with the earth erosion protection frequently is required with the perhaps opposite on the point of entry of the side of the channel with the either erodible area with the made with the concrete other durable material with the inflow brought in over them. Care must be taken to ensure with the positive entry but that there are two methods of conducting stormwater with a concrete line channel. Entry, a large flow with the over the top of the provided with a spillway with a built-in and integral part with a slide slope with a smaller flow with admitted with to the channel by conduity through the side slope with the gating of the conduity with the required with the location we cover them and depending of the brief or not damage cover the tributary the drains ends of the examination must be made to see whether the water is in the main channel and full with the wood cover the damaging back flooding with the tributary area which would be more damaging with the temporary storage of the tributary flow. If so, with the precluding backflow must be employed. This can often be accomplished by a flap gate with the drain outflow outfall with a positive closure required with a slide gate can be due to the flow of the main channel critical to the design of the side of the inlet structure that may require special provision to minimize turbulence effects. 3-3 bridges. Bridge is a structure including support erected over the depression obstructing the trust with water, highway, railway, having track or passageway through carrying of the traffic over moving loads, having the opening measured along with the center of the roadway more than 20 feet between the undercoping abutments of the spring lines of arches, extreme and ends of the opening of the multiple boxes may include multiple pipes with a clear distance between the openings less than half of the smaller contingency opening. Sufficient capacity will be provided with the passive of the runoff from the design storm to determine the quorum of the principle given them below the normally serve the capacity provided entirely with waterway beneath the bridge. Sometimes that is not practical, but must be expedient of the design. One of the both approach with the roadways overflow 6 and 7 with excessive runoff in such event, but it must be remembered the automotive traffic impeded will be stopped together with the overflow depth is much more than 6 inches out of the bridge pipe and proper waterway opening smaller than the required 10-year storm runoff will be justifiable. In general, the lowest point of the bridge superstructure that shall clear the design water surface of not less than 2 feet with the average flow traffic condition. This may reduce a little as 6 inches of the flow quiet with low velocity, little to no trash more than 2 feet will be required in flows of the rough, large side flowing trash anticipated. The bridge waterway will normally be aligned with the result of the least of the obstruction of stream flow, except for the natural stream conservation, given the realignment of the channel to avoid costly skew with the maximum extent practically the abutment will be aligned with the improvement of the flow condition bridge with the span with the improved trapezoidal channel with the considerable width need to overcome economically and may be required with conservation relative to structure hydraulic means merits on bank abutments with or without pier with a warp channel wall of vertical abutments. To preclude the failure of the underscore of the abutment of the pier footing will usually placed either to the depth of not less than 5 feet below the anticipated depth of the score of the firm rock which will be encountered at higher elevation loads and multi-span structures crossing an air-level stream that may require extensive pile foundation protect channel against the increased velocity of the turbulence eddy if expected to occur locally relevant and channel the side of the bottom of the consistent with the concrete grouted rock loose the riprap saturated concrete which place is required. Where flow velocities are high, bridges should be per clear span at practical in order to preclude serious problems attending debris lodgement to minimize the channel construction maintenance costs. It is important for that storm runoff that you control the over such much of the contributing watershed appreciable diversion channel of the terraces check dam with a similar conventional soil with the conserving features will be installed with an implement and improve with the reduced velocity preventing silting of the channel with the over downstream velocity or other downstream facility with practical unprotected soil surface of the drainage area will be planted appropriate to erosion and resisting plan with a part of the drainage area located with a private property otherwise until under control of the others will be conservatively fully with the planning standards stage definite coordinated efforts will be taken to ensure the soil stabilization both upstream and downstream of the construction site. Engineering criteria design principles relate with the traffic side of the low capacity material structural requirements for the highway railroad bridges given the ASHTO standard specification of highway bridges and design manual of the different railroad companies recommended practice area manual of the railway engineering curb and gutter sections precipitation which occurs to open city of the area street for the areas adjacent with the more rapidly economically remove the floor become with the head of traffic the water falling on the movement pavement the surface self-remove the strip of the concentrate of the gutter of the provision adequate crown with the strip of the channel formed by the curb of the gutter must be designed adequately to convey with the running off of the pavement achieving the area with suitable collection point with the capacity made to be kept by either the magnetograph for flow of the triangular channel. Figure 3.2 of the figure can also be used for the bladder curb face section. This battering is negligible, effective with the cross-sectional area limited to with the failed test clear watershed of the main N of 0.013 appreciable for the pavement. The N value should be raised with the appreciable qualities of sediment are present. Figure 3.2 also apply with the composite section compromising 2 or more rates with cross slope. Good roadway drainage practice required with extensive deep of the curb of the gutter of the section of the combination flow will choose from the inlet downspout with the adequate control of the surface runoff, with particular with a highly mountainous terrain where it is necessary to protect the road embankment to get formation rivulet's channel with a concentrated flow. Materials used in such concentration include with the Portland concrete, cement, asphaltic cement, stone rubble soil, side checks, and prefabricated concrete metal sections. Typically on a ladder entrance of tape of the embankment protected with the made of the manufactured corrugated metal products, downspouts as shown small as 8 inches of the diameter may be used unless considerable trash problem exists. In case large size will be required, frequent movement required, and consideration will give given the use of the buried pipe in lieu of an open paved channel with exposed pipe with a hydraulic design. Provisions outflow erosion protection accomplished in accordance with the principles outlined for similar component structures discussed on this mail. Curbs are used with a deteriorated vehicle with leaving the pavement of the hazard point as well with controlled drainage. General class of the curbs are known as per barrier or mountable. Each of these numerous types with a detailed design. Barrier curbs are relatively high, steep face with a design to inhibit it to the least discourage. Then it shows a chart on nomograph flow of the triangle channels. Vehicle from leaving the roadway with a considerably undesirable high speed of the material aerials. Mountable curbs are designed so that the vehicles can cross with varying the degrees of ease. Culverts, a drainage culvert, is defined as any structure under the roadway with a clearly opening with a 20 feet or less measured along the channel of the road. Culverts are generally circle, oval, elliptical, arch, or box cross section, may be either single, multiple construction choice depending on the available headroom and the economy. Culvert materials are permanent type of the insulation include the plain concrete, reinforced concrete, corrugated metal, asbestos, cement, and clay with the concrete culverts may be either precast, cast in place, corrugated metal culverts may either have the annular or helical corrugation of the construction of the steel and aluminum for metal. Culvert is different type of the coating lining is available to improve the durability, hydraulic character of the design. Economical culverts involve the consideration main factors relating with the requirements of the hydrology, hydraulics, physical, environmental input with exterior loads, construction maintenance with the design, discharge, general layout, determine the design requirement of detailed consideration of such hydraulic factors as shape, slope, approach, existing channels, allowable to head, engine with depending capacity, appreciable tail, water, level, the hydraulic energy, grade lines, erosion, potential, selection purposes allowed during the design made a dependent practical consideration of the minimum acceptable slab available to material the local experience concerning the corrosion, erosion, construction, maintenance aspect with few more alternative designs involve the competitive material equivalent may appear to the about equal estimated cost plans will be developed to permit contractors options and alternate bids so the least construction costs will result. In most localities, culvert pipe is available to site with 36 inches diameter for plain concrete to 144 inches for the large reinforced concrete, 120 inches standard, and helical corrugated metal with a polymer with a coated bituminous coated with a paved and fully paved interior. 36 inches for asbestos cement and with or clay, 24 inches for the corrugated polyethanol pipe concrete optical size up to 116 by 180 inches for the concrete arch size with 107 to 169 inches reinforced concrete box section, size 3 by 2 feet by 12 by 12 feet. Available structural plate with the corrugated metal pipes fabricated with a diameter of 60 to 312 inches or more. Corrugated pipe arches generally available to the sizes 140 inches to 91 inches. Corrugated by structural plate pipe arches in a span of 40 feet. Reinforced concrete vertical oval elliptical pipe available in sizes 87 to 136 inches for the horizontal oval elliptical pipe available in sizes 136 to 87 inches. Design extra large size for special shape structural requirements may be submitted to the manufacturers for approval. The fabrication show culverts are used in sidewalks. No entrance way to driveways may be as small as 8 inches of diameter. Plate comparatively free with accumulation of debris and ice. Pipe diameters, pipe arc rises should not be less than 18 inches. Diameter pipe arc not less than 24 inches should be used in areas where wind-blown materials such as weed, sand may tend to block the waterway. Within and above the range of structural requirements may limit the minimum size, so the maximum size that can be used in specifically insulation. The selection of culvert materials withstand deterioration from the corrosion abrasion based on the following consideration. Rigid culvert, preferably where individuals waste with a spilled petroleum product with a substance harmful bituminous paved with a coating of the corrugated metal pipe. Abdomen pressed with the concrete pipe generally should not be used where solvent more acidic than pH of 5.5. Where fluid carry pH is less than 5.5 or higher than 9.0. Polyethanol pipe is ineffective with the acidic alkaline soil condition. Concrete pipe can be engineered to perform various satisfactorily more serving acidic alkaline environment. Type 2 or Type 5 cements shall be used with the soil and or water have moderate high sulfate concentration respectively. Where corrosive substances are to be carried, resistivity qualities in the verified clay pipe, plastic line, concrete pipe shall be considered. Alright, flexible culvert, such corrugated steel pipe with a galvanized, generally with a bituminous coat with a permanent insulation bituminous coating with a polymer coating with a recommend with a corrugated steel pipe subject to the stagnant water wear density decaying vegetation presented with the organic acid where there is continuous wetness continuous flow with well drained, normally dry alkali soils. Polymeric coated pipe that's not damaged, spilled petroleum products, industrial waste, asbestos, fiber treatment of the business coated polymeric coated pipe. Recommend with a corrugated steel pipe subject with a high corrosive soil with tender fall with minimum mine drainage, tidal drainage, salt water spray, certain industrial wastes, other severely corrosive conditions, or where extra long life of desirable catalytic protection is required with a corrugated steel pipe. The insulation in some instances of use may be justified. Corrugated aluminum pipe fabricated in all shapes and sizes. If the more familiar with corrugated steel pipe, evidence corrosion resistant granular materials, even the subject in seawater corrugated aluminum pipe will not be installed in soils with a high acid pH less than 5, alkalinity pH greater than 9, or metal contact metal with the metal deposit where known corrosive conditions present with the battery material corrosion known as this. Some of this type of the pipe is not installed with the classified with the OHOL or according to the Unified Soil Classification System. Although bituminous coatings are applied with aluminum alloy piping, such coating will afford adequate protection. Suitable protective coatings, aluminum alloy, are developed but not economically feasible for culverts or storm drain for flow carrying debris that breaks with a moderate high velocity. Pavement invert pipe appropriate with the protection with the bolt with corrosion abrasion required smooth interior corrugated steel pipe. Made desirable significant addition, providing the desired protection, improve the hydraulic efficiency of the pipe. Usually allowed with a reduction of pipe size with considering coating of the use of performance. Data users in the area can be helpful with performance history, indicate the various successful failures of the coatings and probable causes available to local highway departments. Our capacity of the culvert determine the ability of the convey with a discharge water with the under specific conditions with the potential kinetic energy upstream and the downstream, the hydraulic design of the culvert with the specified design. Discharge involves the selection of the type of the determination of the position, hydraulic control, hydraulic computation determine whether acceptable headwater depth, the outfall conditions will result in the consider with the degree of the detail of the refinement. Its property of selecting culvert side with relatively accuracy with the estimated design discharge should be taken into account. Hydraulic computation will be carried out by the standard method based on the pressure, energy, momentum loss consideration. Rounding, beveling, instruments in any way with increase of the capacity of the culvert, every designation condition. So for every design condition, some of the degree entry for the improvement that should often consider with the incorporate in the design. Head walls to improve the entrance of the flow over the projecting culvert, the particularly desirable with cut off with the prevent saturation law of the inner or erosion embankment. The provision for the drain should be made over the center of the head wall with the prevent scoring along the side of the wall. Minute entry for the conform with the fill slope of the producing little, if any, with the provisions improving the efficiency over the straight and sharp edge projecting inlet. Maybe the structurally unsafe due to the uplift forces, but the times inlet intended to inhibit the culvert flow of the flow of the inlet submerge the most efficient entrance. Incorporate such geometric feature for the elliptical arch, circular arcs, tapers, and parabolical down curves. General 11 inlet design for the culverts are justifiable only in usual conditions circumstances. Outlets and end walls must be protected against the undermined with the bottom of the score with the damaging and lateral erosion, degradation, downstream channel with the barrier present the tailwater highly converter higher than the culvert crown will affect the culvert performance mainly possible to require protection adjacent embankment against wave and eddy current score. And walls outfall head wall of the wing walls should be with the practice with the wing walls should flare one on 8 over the one diameter with the required with the formation of a hydraulic jump establishment or fraud number exit over the channel and stability to general type of the channels and stability developed with the downstream of the culvert. Conditions are known that either gully score or localized erosion referred to the scory hole. Gully score is expected from the fraud number of the flow of the channel exceed with the required with the stability. Erosion of this type may be considered with extent with it depending on the location, stable channel section, relative to the outlet over the both vertical and downstream directions. Core hole can be expected downstream and an outlet even with the downstream channel is stable. The severity of the damage anticipated depends on the condition existing or created with the outlet. See Chapter 5 with additional information on erosion protection. In design and construction of the drainage system, it is necessary to consider the minimum maximum area of the cover allowable to put the underground continuity to place under both flexible and rigid pavement. Alright, infiltration, fine-grained soil within the drain with the pipeline through the joint opening with a major cut with the effective with the drainage facility with the practical with the problem along with the pipe with a relatively steep slope, such with the encounter with the broken back culverts, infiltrating backfill subgrade material that can be controlled with the watertight flexible joint materials, rigid pipe, watertight flow, coupling bands, and flexible pipe resolve with the laboratory reach concern with the soil infiltration through pipe joint, affecting this gaseous tape with the waterproof with the joints and seams available to underground hydraulic design. Storm drainage system will be sufficient capacity for the convey the runoff of the design storm for usually 10 years frequency, permanent installation within barrel with a continuity, concentration times increase with the average rainfall, intensity with the degree with the design with the carry with the set of the downstream points, and generally incremental concentration time with the point-to-point totals with the be estimated with the nearest minute with the totals will be around with the nearest 5 minutes, selecting design intensity with the duration curve with the advantage taken with a permanent variable, shift with the pounding air with effectiveness, determine how order holding design, discharge of the storm drain, the size of the minimum experience to indicate with the feasible with the practical with the actual design of the storm drain, the added minimum value with the concentration 10 mils from paved areas, 20 minutes from turfed areas, minimum time with the concentration should be selected with waiting, combined paved and turfed areas. Storm drain systems will design hydraulic grade line product, computed pit design discharge with the near optimum depth with practical velocity not less than 2.5 feet per second with a nominal minimum cleansing with a drain with a 1/3 or more full, minimize the possibility of clogging with a facility with a cleaning with a minimum pipe diameter box section height with a generally not less than 12 inches, usually smaller size must be justified. Problems in contending high velocity should be carefully analyzed with appropriate provisions made to ensure the fully protection, full functional project. Site topography will dictate with the location possible outlet with the general limiting grade with the system. Some storm drain depth will be held to a minimum consistent limitation both with the cover the requirement, the proximity, other structure with the interference with the other utility velocity and requirements with the deep excavation expensive usually provide with the proceeding with the downstream ground continuities used with the side with the progressive the creep will be mass inverted grade to pro or dropping cover the junction structure similarly with the crowns and coming laterals will be matched with that with the main line of downstream continuity smaller than on steep slope the invert will be matched with the upstream continuity. Some additional lowering with the outgoing pipe with the may require to compensate with the pressure loss of the junction structure. Manhole and junction. Boxes usually provide with the point of the discharge of the continuity grade size of the junction lateral branch with whenever the entry of the maintenance with the required distance between the points. Entry will not be more than approximately 350 continuities with minimum dimensions smaller than 30 inches of the storm drain will be carrying water velocity of 20 feet per second with a greater with a high energy strong force present. Special attention must be given to such items alignment, the junction, anchorage requirement of joints and selection materials. Inlets. Just checking. Alright, we're going to cut the tape there and, we'll read to page 31. Storm drain inlet structure intercept with the surface flow with the three general type of the drop of the curb. The combination hydraulically may function either weirs or orifices depending on the mostly with the inflow of water allowable to depth of the design storm conservation consequently type of the space inlet but depending on the topography of the surrounding areas and use the consequence of depth drop limits are provided with the graded entrance of the opening are generally more efficient with the curb inlets useful some with the roadway side with the rail with the gutters sections and lens commonly depressed below with the adjacent grade with the improve the interception increase the capacity curb inlets along sloping gutters required with the depression adequate intercept of the combination of inlets may be used with some of the additional capacity the restricted space desired simple graded with the inlets of the most suspect with blocking the trass although other housing areas used with the graded drop inlet should be kept at a reasonable minimum with the preference from the beginning given the curb type of the opening with the abnormal high curb opening it is needed with the pedestrian safely may less suspect will block with the dry trash. Although efficient with the interception hydraulic steep slope of the base cover, the difficulty turning flow into them. Assuring of the satisfactory performance of any system inlets required with careful consideration of several factors involved. Final selection inlet types will be based on the overall hydraulic performance, safety requirements, reasonableness, cost of construction, and maintenance. In place inlets, and then we're going to cut the tape there.